Now observe the numbers 10, 50, 250, 16, 40, 240. So all these numbers are having 0 in its units place. Therefore, we say that they are divisible by 10. So 50 is 10 into 5 and 1640 divided by 10. 10 ones are 10, 6 remaining, bring down 4. 10 6 are 60, 4 is remaining, bring down 0. 10 4s are 40. So these numbers are exactly divisible by 10. So what is the test for divisibility of 10? If the numbers are having 0 in its units place, then we say that these numbers are divisible by 10. Now observe the numbers. Six, 12, 114, 18, 126. First thing, when we observe these numbers, we see that these numbers are having 2, 4, 6 or 8 in its ones place and they are even numbers. Therefore, they are divisible by 2. These numbers are divisible by 2. And no, 6 is divisible by 3 because 3 2s are 6. And what about 12? 12 is also divisible by 3. 3 4s are 12. What about 114? 114. How to check for the divisibility of 3? We have to add the digits. That is 1 plus 1 plus 4 is equal to 6 is divisible by 3. And what is 18? Exactly, it is divisible by 3. 3 6 are 18. What about 126? 1 plus 2 plus 6 is equal to 9. And 9 is divisible by 3. So, these numbers are also divisible by 3. So, the test of divisibility for 6 is the number should be divisible by both 2 and 3. This is the divisibility test for 6. Now observe the numbers. 3, 1, 2, 16, 1, 2, 4, 9, 3, 6, 5, 2, 0. Consider the last 2 digits of these numbers. What are they? They are 12, 16, 24, 36, 20. These are the last 2 digits of the given numbers, means in ones place and tens place. Ones place, tens place, ones place, tens place, ones place, tens place, one place, tens place. They are the last two digits of the numbers. And what do you observe? Are they not divisible by 4? In 4 times tables, do they come? Count the tables. 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 six are 24, 4 6 are 36. So these numbers formed by last two digits of the number are divisible by 4. Therefore, these numbers are divisible by 4. Can we check it? 312. So by long division, we check the divisibility of 4. 4 sevens are 28. 3 is remaining. On subtraction, 28 from 31, we get 3. Bring down 2. 4 eights are 32. So, we conclude that 312 is exactly divisible by 4. What about 936? 4 twos are 8. On subtraction, we get 1. Bring down 3. 4 threes are 12. On subtraction, we get 1. Bring down 6. 4 fours are 16. So, number 936 is divisible by 4. What about 124? 4 threes are 12. Bring down 4. 4 ones are 4. Similarly, you can check the number 520 also. On long division, you conclude that these numbers are divisible by 4. So, what is the test of divisibility, or how to check whether the given number is divisible by 4? We have to consider the last two digits of the given number. If the last two digits of the given number is divisible by 4, or that number, if it is the multiple of 4, then we conclude that the given numbers are divisible by 4. However big the number may be. You have learnt about the larger numbers also. So if you are given any big number, just consider and observe the last two digits of the given number, that is in ones place and tens place. If it is divisible by 4, or if it is a multiple of 4, then the given number is divisible by 4. This is the check or the test of divisibility for 4. So till now we checked 2, 3, 4, 5, 6, 10. So what about 8 and 9? What about 8? How we checked with numbers 4? We have to check same way for the number 8. There we have to consider the last 3 digits. That is, observe the numbers 816, 4104, 4104, 5632, 'Consider the last 3 digits. These digits. If they are divisible by 8, we have to check with the long division, and it is not so time consuming. 816 divided by 8. 8 ones are 8. On subtraction you get 0. Bring down 1. You cannot divide 1 by 8. We have to put 0. Means 8 zeros are 0. Then bring down 6. 8 twos are 16. So this is how we divide and check the divisibility of 8. Dividing 816 by 8, we get remainder as 0. Therefore, we say that 816 is divisible by 8. And what about the number 4104? We have to check for 104. 104, if you divide by 8, 8 ones are 8, you get 2 on subtraction, bring down 4, 8 threes are 24. Because 104 is divisible by 8, we conclude that 4104 is divisible by 8. And consider the number 632. We'll check whether it is divisible by 8 or no. 8 5s are 60. 3 is remaining. Bring down 2. 8 4s are 32. So, we observed here that 632 is divisible by 8. Therefore, the number 5632 is divisible by 8. This is the check or the test of divisibility for 8. And now, what about 9? There, you have to check the divisibility of 9 by considering the sum of the digits given. Consider 27 and 63, 72 and 648 and 225. If the sum of the numbers, the digits in the numbers is divisible by 9, then the number is divisible by 9. 2 plus 7 for 27, 2 plus 7 is equal to 9. For 63, 6 plus 3 is equal to 9. For 72, 7 plus 2 is equal to 9. For this, 6 plus 4 plus 8 is equal to 18. And for this, 2 plus 2 plus 5 is equal to 9. So, all these numbers, the sum we get by adding all the digits of the given number for which we are checking the divisibility of 9 is divisible by 9. The sum is divisible by 9 in each case. Therefore, we conclude that all the 5 numbers given here are divisible by 9. So, these are the tests of divisibility of numbers. Now consider some numbers. 4, 1, 8, 1, 0, 4, 5, 9, 5, 7, 1133, 1232. Let us play one game here. Okay, let us play with these numbers. What it is? The digits in odd places. That is first place, second place, third place. This is ones place, tens place, hundreds place. We know that this is ones place, this is tens place, this is hundreds place, this is thousands place. Okay, this is first place, 8 ones place, tens second place, third place, fourth place. So consider the digits in first place and third place, 4 and 8. Let us add them. We will get 12 and the even numbers. Digit in the even number. 12, minus 1 is equal to 11. What we did? This is 1. So this 12, consider 12 and 1. Okay. In number 418, we considered digits in first and the third place, that is odd places. 4 and 8. Find the sum. We get 12. And the digit in the even place is 1. And take it as 1. Take the difference of these two. 12 minus 1. We get 11. Now, this number. Digits in odd places. 5 plus 0 is equal to 5. And digits in even places. 1 plus 4 is equal to 5. Now take the difference. 5 minus 5 is equal to 0. Consider the number 1, 2, 3, 2. Here, digits in the odd places. 2 plus 2 is equal to 4. And digits in the even places. 3 plus 1 is equal to 4. And take the difference. 4 minus 4 is equal to 0. And consider number 1133 or 957. Let us take this number. Digits in odd places are 9 and 7. 9 plus 7 is equal to 16. And digit in even place is 5. So taking the difference, 16 minus 5 is equal to 11. What did we observe here? (418). We added digits in odd places. 4 and 8. It is 12. And digit in even place is 1. So if you take the difference, 12 minus 1 is 11. In the second number, digits in the odd places. 5 plus 0. We get 5. Digits in the even places. 1 and 4. If you take the sum, you get 5. And if you take the difference, it is 0. And this number, 1232. Digits in the odd places are 2 and 2. So, taking the sum, we get 4. Digits in the even places are 1 and 3. So, if you add them, you get 4. And taking the difference of these sums, we get 0. Here, for the number 957. Digits in the odd places are 9 and 7. So, taking the sum, you get 16. And digit in the even place is 5. Subtraction gives us difference as 11. So what we did, we took the sums of the digits in odd places and even places separately. Their difference gives us 0 or 11. If this is so, if the situation is like this, then the given numbers are divisible by 11. So what is the check or the test of divisibility for the number 11? Consider the given number, then take the sum of digits in odd places and sum of digits in even places and their difference. What should you do? Sum of the digits in odd places, sum of the digits in even places and their difference. Sum of the digits in odd places, sum of the digits in even places and their difference. If it is 0 or 11, then we say that the number is divisible by 11. Why we learn these divisibility tests? Because it makes us easier in our further studies. So let us continue in our next class. Till then, I will make a chart of these divisibility tests. You also make a chart and keep it on your study table so that whenever you are asked to find the factors or the prime factors, I will explain it in the next class. You will need this chart. So please prepare a chart and keep it on your study table. Let's continue in our next class.